Advanced Math, Set 102, Binomial Expansions, Part 2. So, if you remember back to Lesson 77, we did binomial expansions before, and we used Pascal's triangle, which looks like this. And basically, the way that we used it is if we had an expression that was a plus b quantity raised to the 0 power, we would use the first row. To the first power, would use the second row, and so on. Second power would be the third row, and so on. And these values 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, those became the coefficients of the pieces in the expression. So when we talked about exponents, what we would do is we would, for the variable a, the exponents would be descending in order. So for a plus b to the 6th power, we would start with the 7th power and then move down to the 0 power. And then for b, we would start at 0 and go up to the 7th power. This should be kind of a review. When we're dealing with 5 to the 5th power, we would go, actually that is not right. Sorry, I just realized that as we were talking about it. For a plus b to the 6th power, you would start with 6 and go down to 0. And then you would start at 0 and go up to 6. And then for the 5th power, you would have to the 5th, and then you'd go up. And then so on. So for a plus b to the 4th power, you'd start with a to the 4th and then go down. So let's just put this to practice. So it says find the 4th term of negative 3x plus 2y squared all to the 4th power. So what we're going to do is we're going to make it look like what we're used to doing and make it look like f plus s raised to the 4th power. F represents the first term and s represents the second term. So we're going to let f equal negative 3x and we'll let s equal 2y squared. And we'll just make this little table that has the term number, the exponent of f, the exponent of s, and the coefficients. So we will have 5 terms. Because it's raised to the 5th power, you always have one more term. Then you have exponents. And the exponents are going to start at 4 and go down to 0. The exponents of the second term are going to start at 0 and go up to 4. And the coefficients are going to be just like that, what was it, the 5th row of the Pascal's triangle. So 1, 4, 6, 4, 1. So it says find the 4th term. So we're going to just concentrate on that column. And that column says that the exponent of f is 1, so it's raised to the 1st power, and s is raised to the 3rd power, and the coefficient is 4. So we have 4, s to the 3rd, f to the 1st power. So 4, and then we said that s was 2y squared, and we're going to raise that to the 3rd power, and then f raised to the 1st power, so negative 3x raised to the 1st power, and then we just simplify. So we'll do 4 times 2 to the 3rd power is 8, y to the 2nd to the 3rd power is y to the 6th, and then negative 3x to the 1st power is just negative 3x. So when we multiply 4 times 8 times negative 3, we get negative 96, and then we have x and y to the 6th. So the 4th term of that expansion is negative 96x y to the 6th. Our next example is going to be a little bit more drawn out because it just says expand this expression, 2a squared minus x cubed all to the 4th power. So what we'll do is we'll first substitute f plus s in for 4, let f equal 2a squared, and let s equal negative x cubed, and we'll make our table. It's going to have 5 terms. The first is going to go from 4 in descending order, and this second is going to start from 0 and then ascending order, and then our coefficients, 1, 4, 6, 4, 1. Now in this case, it says we're expanding the whole thing. We're not looking for a particular term, we're looking for all of the terms. So we'll start out with the first one, which the coefficient is 1. So we're starting here. The coefficient is 1, and then f to the fourth. Since s is raised to the 0 power, I'm not even going to write it down. Or actually, yes I am. Okay, so 1 f to the fourth, s to the 0. And then 4, and we have f to the third, s to the first. Then we'll have 6 f squared s squared. Then we'll have 4 f to the first, s cubed. And then 1 f to the 0, s to the fourth. Now we take those f and s up at the top and we'll plug those in. So we end up getting 2a squared to the fourth power plus 4 times 2a squared to the third power times negative x cubed plus 6 times 2a squared squared minus x cubed squared plus 4 times 2a squared negative x cubed cubed plus negative x cubed to the fourth power. And from here you just simplify. 2 to the fourth power is 16. A squared to the fourth power is a to the eighth. Then we have 2 to the third is 8. 8 times 4 is 32. A to the sixth power, and then I forgot to do that negative sign, so we'll have to change that. So it's x cubed, and instead of positive, it's negative. So negative 32, a to the sixth, x cubed. Then moving on to the next one, we have a negative that's squared, and then 2 squared, which is 4 times 6. So we have 24, a to the fourth, and x to the sixth. Okay, the fourth term, we have a negative cubed, so we know it's going to be negative. And then 2 times 4 is 8, a squared, and then x to the ninth. And then the final term is negative to the fourth, so it's positive, and x to the third to the fourth is x to the 12th. And that is our solution. Okay, final one. Find the third term of negative 3x plus 2y squared to the fifth power. So we'll substitute in f and s. So f is negative 3x and s is 2y squared. We'll make our table. So we've got our terms, our exponents, and the coefficients. So again, we get our exponents because you just take the power that it's raised to. The first one's going to descend, the second one's going to ascend, and then coefficients come from that Pascal's triangle. So you just go down to the corresponding row. Now we're looking for the third term. The third term, we know the coefficient is 10, f to the third, s to the second. And then all we have to do is plug in f and plug in s. So we get 10 times negative 3x to the third times 2y squared to the second. So we get 10 times negative 27x cubed times 4y to the fourth power. Negative 27 times 4 times 10 becomes negative 1080, x to the third, y to the fourth. And that is your third term.